Okay, welcome back everybody. This is Mobile12. For this video, I'll be talking about the Wolf-Kishner Deoxygenation. It's a very neat reaction. It only works with aldehydes or ketones. So if your starting material is an aldehyde or ketone, this reaction works perfectly with those starting materials. So for this reaction, I will not be talking about the reaction mechanism because it is a long reaction mechanism and it's going to take a lot of space and time. So for this video, I'll be specifically focusing on just the reaction, and maybe in a later time, later down the road, I might just go and make a video on the reaction mechanism. So let's get started, okay? So again, this is known as the Wolf-Kishner, hopefully I'm spelling this correctly, deoxygenation, okay? Okay, there we go. See, that's why I'm a chemist, okay? I cannot spell properly, and forgive me if I can't spell that correctly. So, for this reaction, if you start off with an aldehyde or ketone, and you react it with NH2, NH2, NaOH, and heat, okay, so aldehyde or ketone plus NH2, NH2, NaOH, and heat, okay, that's what that little triangle symbolizes, heat. This will generate an alkane, okay, so you generate an alkane from this reaction, and again, this reaction specifically works with only aldehydes or ketones, okay. So one more thing I want to talk about before I get into some examples is your star carbon. And if you've seen my videos on imines, you'll know what the star carbon is. The star carbon in this case is the carbon of your carbonyl. And what carbonyls are we talking about? Because this is a very broad term, carbonyl, because you have aldehydes, ketones, esters, carboxylic acids, acid chloride, so on and so forth. So we're talking about specific carbonyls, okay? And the specific carbonyls we're talking about are the aldehydes or ketones, okay? So keep that in mind. It's not any carbonyl, it's aldehydes or ketones, okay? So I'll just make a note about that. Sorry about that. So aldehydes or ketones, okay? So what you want to do with the star carbon, the point of doing this or labeling your star carbon is that it helps you when drawing the product, okay? Because all the reaction mechanism takes place and focuses on that specific position, that star carbon. So if you can identify that star carbon, basically the carbon of your aldehyde or ketone, it will be really easy to draw the product, okay? So whenever you want to get into the habit of labeling your carbon of your carbonyl with a little star, and at the end when you make your product, then get rid of your that little star, okay? And you'll understand what I'm talking about as we go with this, as we proceed with the examples, okay? So again, aldehyde or ketone, NH2, NH2, NaOH, heat gives you an alkane. Make sure you label your star carbon, which is the carbon of your aldehyde or ketone, okay? So let's go over some reactions, okay? Some examples. Okay. So, let's just start off with a nice and simple one. Let's just say you have this aldehyde here, okay? Again, you react it with NH2, NH2, NaOH, and heat, okay? So NH2, NH2, NaOH, and heat. Now we're going to get into what the product will look like, okay? So again, you want to identify and label your star carbon, which is the carbon of your aldehyde or ketone. So in this case, we have our aldehyde. You want to label it with a star, because that's the carbon of your carbonyl. And all we will do to draw the product is draw the starting material without the double bonded O. Because the Wolf-Kishner Deoxygenation, all it does, it removes the double bonded O. So our product will look something like that. Okay, and we could draw in our star carbon just to make sure that we erase the proper thing. Okay, so there you have it. There's the product. And when I told you guys earlier, make sure you erase your star, the star that you label. The reason why I said that is because that little star looks kind of like a radical, and professors or teachers might think that you're drawing in a radical or something like that. So make sure you erase it at the end when you finally determine and draw your product. Okay, so that's all it is to this reaction. Okay, all you do is remove the double bonded O. There you go. And it's not any type of double bonded O. It's the double bonded O's that make an aldehyde or ketone. Okay, so in this case we had an aldehyde. So let's go over another reaction, another example. We'll leave the reagents. We'll leave that alone. We'll erase that because it's the same set of reagents we use for every example. Okay, so let's just say we have this now. Okay, this starting material. This molecule here is known as cyclohexanone. Again, cyclohexanone. Okay, so again, you want to identify your star carbon. There it is. And in this case, this is a ketone. All we will do in order to draw the product, we'll remove the double bonded O, and we'll end up with our product right there. So that's our star carbon. That's where the double bonded O was initially located, but now we deoxygenated it, we reduced it, and that's how we got this alkane here. Okay, so there you go. That's your product for this reaction. Again, you want to erase the little stars so the professor does not get confused with that being a radical. Okay, so again, that is the product from this reaction here, from the starting material. Okay, let's go over one more example because I think you guys are getting the drift of how this works, and I don't want to make this video long. Okay, so the final example we'll go over is this here. Okay, so now I say, what draw me the product? Okay, in this case, some of you guys may be thinking and might draw this as your product. Okay, you guys might draw this as your product. Okay, so some of you guys may draw that. Okay, but because you guys reduced this carbonyl and this carbonyl, okay, you guys got rid of both of these double bonded O's. But remember what I said earlier. We only remove the double bonded O's that are attached, that make up an aldehyde or ketone. This here is your carboxylic acid, and here is your ketone. Remember, I said this reaction only works with aldehydes or ketones. It does not work with carboxylic acids. So this here is wrong. Okay, that's not the answer. The answer in this case would be this. Okay, this right here is the answer, because remember I said that we only reduce the ketones or aldehydes, not carboxylic acids or any other carbonyl. Okay, so that's your product. Okay, and that's the only star carbon that we had right there. Okay, and at the end you want to make sure you erase it so the professors don't get confused or whatever. So that's all it is for this reaction. Okay, so yeah, I'll leave you guys with that. Thank you for watching, and stay tuned for some more videos.